Here we go. Question 9. Right, circles. Finally time to get round to that. Thanks for the sympathetic laugh. Okay. There's the equation of our circle, and the question says find the coordinates of the centre of the circle and the radius. So we need to get it into that form that we just talked about, x minus a squared plus y minus b all squared is r squared. Right. You can do this as quickly as you want to, but I might rewrite this so that I've got things in order. There's my x squared minus 2x. I'm going to leave a little gap. Here's y squared plus 10y. I'm going to leave a little gap, and I think I'm going to take the 19 over to the other side and write it like that to start with. Now remember what we did to complete the square. We want to add in half the coefficient of x when you square it. So a half of minus 2 squared, half of minus 2 is minus 1, squared is plus 1. I'm going to put a plus 1 there. I need to keep my equation balanced though, don't I? So over here I'm going to put a plus 1 to keep it balanced. Then I've got a 10y here, so half of 10 is 5, squared is 25. I'm going to add in 25 there. And in order to keep things balanced, I'm going to put a plus 25 over here as well. The whole point of doing that is that what we've just done is these first 3 terms here, and these 3 terms here, they are now complete squares because that factorize these. So this first bit is what you get when you multiply x minus 1 by x minus 1. And the next bit, with the purple number in it, is what you get when you square y plus 5. And over here, we've carefully added these together. We've got 19, add 1 at 25, which is 45. So we've got 45 in there. And the question said, find the coordinates of the centre and the radius. So the centre is the point 1 minus 5, and the radius, well, 45 is the radius squared. So the radius is the square root of 45, which that might be enough for us. I'd like to write that in its simplified form. I didn't ask us for a simplified third form, so I'm not sure we might get it for root 45. But what 45 is 9 times 5, isn't it? So we're going to write that as 3 root 5. There we are. Okay, great. 3 marks. Verify that the point 7 minus 2 lies on the circumference of the circle. Verify questions are really dull. All this really means is sub in the values x equals 7, y equals minus 2, and check it fits. So we'll do it in our original equation. 7 squared plus minus 2 squared minus 2 times 7 plus 10 times minus 2 minus 19 equals 49 plus 4 minus 14 minus 20 minus 19 which is, what is that? 53. Take away, and we should have 53 there, we have, haven't we? Which equals 0. Therefore, 7 minus 2 is on the curve, is on the circle. Okay. It's a really tame kind of question, that, isn't it? Just to verify that. Especially when the point 7 minus 2 is such an exciting point. Because it's living on the edge of the circle. Right. There's a jump. Part 3. Find the equation of the tangent of the circle at point 7 minus 2, giving your answer in the form like that. Whoa, and suddenly, after a really tame first 4 marks of this question, they throw this at us, and this feels like a much bigger deal. So, do we feel the need for a little diagram first? Look at that. There's our circle. We know that the centre of the circle is the point 1 minus 5. We're dealing with the point 7 minus 2, which is a bit scary. That's over here somewhere. There's the point 7 minus 2. And we've got a tangent to that. Oh, that was quite wrong. There we go. Right. So what do we know? We know that the radius at that point, there it is perpendicular to the tangent. We've got a point that the tangent goes through, that's great, 7 minus 2. We need to know the gradient of the tangent, so I need to know the gradient of the radius first. And the radius gradient I always feel that the radius gradient should have its own name. The radiant. Quite a nice idea. Or the gradients. The radius gradient would be, so that's the change in y, so the change in x, minus 2, minus 5. Wow, we've got another minus going on. This paper is full of them. What am I doing? 7 minus 1 down there. That gives me 3 over 6. Ooh. Which is a half. But my tangent is perpendicular to that, isn't it? So right angles to it. So the tangent gradient, this is where I get to use my negative reciprocal bit that we talked about in the straight line graph thing. Minus 1 over a half, which would be minus 2. So my tangent goes to the point 7 minus 2 with a gradient of minus 2. And so this is where I get to use, we didn't do it in the straight line graphs question, did we? But we promised that that equation, you can expect it to come up on almost every module. Y minus y1 is m x minus x1. There we go. And so we get y plus 2 is minus 2x plus 14. So 2x plus y minus 12 equals 0. And there we have our tangent of the circle at point 7 minus 2 in the form ax equals by plus c equals c. There we go. Right. Okay. Everybody happy? That's maths.